for data science work, me and my colleagues spend around 50% of our time for just curating the data, cleaning data, turning raw data into a format where we can actually do statistics or AI research. Thanks to large language models or Gen AI assistants, that part became substantially easier. I studied bioprocess engineering, then did a PhD in neurobiology, where I picked up bioinformatics, biomedical imaging, computer vision. Since 2017, I'm with Bayer. Mostly, I did work in algorithm development, and there was always some component of image analysis to it. I spent some time in agriculture technology as well, developing apps to classify plants or diseases on leaves of plants. I later switched to the radiology domain. So it's medical images, but nevertheless, the technology is the same. The parts that we are going to see for the data curation is more or less agnostic and stable across those different domains. Now, how do AI, large language models, and foundation models relate to each other? It really helps to demystify this concept a bit. I've seen projects and discussions where basically we just refer to AI as magic. So assuming I have a task to solve, let's say I want to clean and curate 1 gigabyte of data in tables, I want to use magic to have harmonized data ready for analysis. So the big names of Silicon Valley, what they are really good at is taking heaps of data that they source and collect and then pre-train a gigantic mathematical model. This pre-training, only a few organizations in the world are actually capable of doing. It's meant to be the foundation of whatever comes afterwards. They refer to that model as foundation model. And those foundation models can be used as is via prompting. If it's a text model, there are also image foundation models. Then the foundation model answers or responds based on the external data that it has seen. One can use large language models or foundation models for translation, for text generation, code generation, and factual question answering. Code generation and factual question answering are powerful pieces for researchers because it opens up possibilities how we can do research on a specific question at hand. Specifically, the prompting happens in natural language. We can basically tell in regular language what those AI models are supposed to do. For instance, create code or find that needle in the haystack, but it basically requires somewhat to lean into this concept as a subject matter expert, as a biologist, as a chemist, as a researcher in biodiversity. Basically, I can just encourage that the amount of knowledge it requires to build your own software tool or to run a bit of code and a bit of Python is really minimal. And also you learn on the way, so you get more comfortable as you start to use those foundation models. Due to the massive scale of the input data, we also see emergence of new capabilities. That's actually an interesting fact. So basically, there was no formal way of teaching the LLM to write poems, or in scientific terms, to maybe connect the dots between a physical appearance, phenotype of an object, of an animal or plant, and maybe connect it to where does it show up in a different piece of data asset or data set. If you have maybe a table with images plus names, and then in yet another table, there's only the names, basically the LLMs or the AI can connect those concepts. If you are a bit skeptical, can it actually help me with my task? Maybe the LLM you choose is not smart enough. It is a proven strategy to just wait. You can wait for 6 months, follow the news a bit. Maybe there are new kinds of large language models popping up, and then try again. There's a high chance that next time around, the task that you tried to solve and didn't work out then works out. Large language models do have limitations, usually around logic and reasoning. If you need LLMs for a certain task, you can look for benchmarks. mathvista.github.io is about math reasoning. Let's say it shows an image here, and then subtract all metal blocks, subtract all large brown blocks. How many objects are left? That's not something that you can just formally teach a piece of software, but eventually I assume AI models are capable of answering this. What is the age gap between these two people in the image? In order to answer this, the AI needs to do different subtasks and then get to the answer, recognizing those people in the first place. As practitioners or as scientists, we are overwhelmed with just a variety of models. Some are specified or specialists for image classification or text classification. Some are video classification. Some are domain specific, like radiology, health, and life sciences. And some are just generic. And even those have different sizes, different degrees of performance, and different costs associated to it. They are served by a cloud provider, so you don't install this on your laptop, but you query those from the cloud. Then it needs a bit of research, or maybe you just ask a colleague or someone who knows which one is the right one to choose. Overall, I mostly go with the fastest, smallest, cheapest, because they all rise with the tide. The ones that are now available are generally very good for data cleaning, for harmonizing. There's no need to go for the frontier model. My use case that I picked basically work off of a data set that's available publicly from the Global Biodiversity Information Facility. It has a DOI, can be downloaded, and it is from the Senckenberg Institute. The flag here has no coordinate. That's my task. That means it has no GPS coordinate. It has no numerical definition of the location. Rather, it's written as natural text. And it also consists of multiple data sets. Here you can already imagine if you pull from different data sets, they vary in how they've been built and collected, etc. So that already explains a bit why most of us, if we work on raw data, spend so much time, up to 50%, sometimes 70, 80%, just cleaning data, because just combining data sets is tedious and time consuming. Real world data can be very raw. And here we see a bit of code now, but essentially what I want you to look at, this data set has 38,000 rows, entries. If we just look at the locality column, then this is what we find. We see sometimes this column or this row column combination is empty. Then we have a German description of a place. Then we have two similar places, but it's not harmonized. One is called Grand Cayman, Karibisches Meer, Caribbean Sea, and in the next row it's only Grand Cayman. Then it's Caribbean Sea, period, comma, Grand Cayman. So obviously you cannot just do statistics on those. First, it's in German. So if we work across languages and entities, we might want to harmonize the language, most likely English. Doing this by hand is very time consuming, as you can imagine, but that's something where LLMs are actually really good at. My question is it possible to get latitude, longitude for all entries, harmonize the locality data so that we know country, municipality, city in this order for all those places in a separate column? that the guesswork of the exact place also considers the other columns, not only that one locality column where it said Caribbean Sea, but maybe other columns can be indicative of what is the actual place where that object got sampled or collected. Then mark uncertainty and correct typos. When we talk or interact with large language models, we do this via natural language, as said, and then it can follow a certain structure of those prompts. So in that example here, given a story, please restructure the contained data. Then there is a story that's the context. In this example, this is around computational resources for students. The task here is restructure the story and only provide those two numbers, number of students and cloud storage. Basically break down, make it very simple and intuitive for the large language models to fulfill our needs. You can upload books of data and heaps of tables, and they will fit into those large language models as part of the prompting. Just be aware that the working memory of large language models still has limitations. I apply LLM reasoning and provide and create a harmonized and cleaned description of a place. And then with this new column, I can do geocoding. And essentially, that's something where open source software served a very good purpose already. GeoPy is essentially a fantastic tool where one provides natural text description of a place, and in return we get GPS coordinates or latitude, longitude coordinates, which can now be added back to our table in yet another column. So what we then have in our hands is a cleaned and enriched data set. That loop should be more or less automatic. The code example can be downloaded from this URL. It's on GitHub and public. In my case, I use Google Colab to run the code, but the code also runs on your laptop if you have the right infrastructure to execute this. It's relatively cheap. You don't need to go for a full-fledged cloud account or buy an expensive piece of hardware that sits under your desk. And there is free tiers, so you don't actually pay anything. My development work that I do for the museum, I do in Google Colab. Again, we need to construct the prompt in a certain way. This is what I did. I used two prompt commands back to back. The first one, it's written here. I define the role or the story. Your job is to guess the geographic location based on the description and keywords. Also fix typos and translate to English. The LLM does exactly this, takes the raw locality description and provides a new output. This new output goes into a second LLM, or actually it's the same one, but we just run it back to back. And here, convert the input into a structured output that looks like this: continent, country, city, name of the place or object. Everything separated by white space, typos are fixed and translated to English. Only provide a single line of output. Never output any additional text. So this is then something that can go into our column of the clean version of the location. That's really it. The parts below here, this is syntactic sugars. You can copy and paste just from my code example. It basically only says we are running this back to back. So first the template one, and then the prompt template, and then we use the other chains. In LLMs, we refer to chains to do this. If you're interested in more and how to run this and even have more sophisticated setups, this is using the LangChain library, but actually we don't need to know the details. So what then happens if we have a location called Brandenburger Tor, first the German language, then there is a typo, so capital O, but we want to have it harmonized according to our standards, then this LLM chain would translate this into Europe, Germany, Berlin, Brandenburg Gate. Same Eiffelturm would be turned into Europe, France, Paris, Eiffel Tower. Mount Cook would be turned into Oceania, New Zealand, Southern Alps, Aoraki, Mount Cook National Park. It can even be more obscure in a sense that the location is more a description of a place. Biggest city of the country where Kiwis live. LLMs actually can do the reasoning and then still translate or harmonize the description into New Zealand, Auckland. With this more clean version of the place description, we can then go to GeoPy and basically get back more specific information like GPS coordinates, size, width and height, or east-west distance, north-south distance of a place. And that's really something that we can now use for creating figures or maps or for statistics. I just want to point out there, this is the part where we can hit different services in GeoPy. Here I work with Nomi Natim and Google V3. There is a part where I need to provide a key, and this is all described in here. So just follow the instructions, so to say. And then it imports a lot of code. For the LLM part, this was actually a bit tricky if you don't really know. To use Google LLMs, it's just a few clicks. You need to know where to click. Visit AI Studio URL. Then it'll ask you to log in with the Google account. And at the bottom left, there is a link. It reads Get API Key. Then follow the instructions. So it asks whether you want to have a new key or you want to take a key from a different project, etc. Essentially, you get this long key, which is letters and numbers, and then you copy and paste it into Colab here. If you work in a different environment, so not using Colab, but something else, or in your institute, then it's in a very similar fashion. And so I have saved my credentials or my keys in here. So I have a Maps key and a Google key. Those allow me to use those services because they are not public. Now I can actually start to execute the key or execute the cells. Basically, it pulls the key and then gives it to a GenAI client. So this one is connected with Google now. And then I do a sanity check. I want to just see which models does Google have currently. Obviously, the list is very long. I don't read this, but what it tells me, my Colab, my code can communicate with Google. That's all what I want to know for now. This part here, this is now specific to my tasks. I need to provide some configurations to my model and also select a model. I showed earlier, there's so many models out there. Just pick something that's not too expensive, that's maybe fast. Gemini 2.0 Flash is something I can recommend and that I used here. The rest is you can go with the default. Then I do another sanity check where I want to specifically access and use this model that I've chosen here. So this is just a one-liner. It says LLM, so this is the object behind the equation, invoke, and then this is natural text. Tell a dad joke that contains the word dinosaur, later provide German and Spanish and Italian translation. And here we go. So that's how you work with those LLMs. Very easy. Then I move on to my actual task. This is the prompts that we looked at earlier. So I construct those two prompts. The first one basically removes the typos and translates to English. The other one harmonizes towards continent, country, city, and then takes out all the white space. I need to provide those instructions also. This part looks a bit nasty and not very clean, but in essence, it runs, it executes properly. So it should just provide output as what are the GPS coordinates, then what is the north-south, east-west distance. There's a bit of math in here. And then the next function I was interested, what's the greater circle distance between the two most extreme points, if I want to have some proxy for the size of my place. Def basically means function definition in Python. Now I can test run this already. I give it a query. So here I go with Copenhagen Zoo. It sends it to the LLM, and after that, it sends it to GeoPy. Now what we see here didn't work. OpenStreetMap is blocking our access because last night when I looked at the code, I tried a bit too often. It's just not nice to send thousands of requests to a service. Now Google helps me, or the AI inside Colab, to make sense of this. And it provides me a fix. And that's essentially how you can go forward with your own solutions. I'm not even getting nervous when I see those kind of errors. I just ask a coding LLM, explain what this is about and how to fix this. Basically, I provided earlier already half the solution because I would now switch to the Google service and take this one instead, with the hope that basically this one works better or it works in the first place. In the code example, I then actually download the table data that I introduced earlier. Again, if you don't know those Python codes here, use the coding assistant. You can literally take the URL from any place and then tell it, write Python code that downloads the table and loads it into Python. This is the URL. I hit go. It comes up with a proposal, and for a non-coding layperson, you basically just hit run if it works. After some time, you can actually eyeball a bit. Okay, does this look correct and proper? Lastly, to connect all those parts, we want to go through each row in our table, get the coordinates and write them in a separate column. So I would give it a try with the coding assistant. I write one big prompt directly describing what I want to have. I cancel this. I just copy paste the prompt. Now it'll go ahead and develop some more code and maybe ask me some questions on the way, whether this is the right thing to do. It breaks it down into different subtasks. And then I say run step by step. So I can actually follow along how this works and maybe also correct if I'm not agreeing with what the assistant does. This runs a few minutes. What's missing is the export, because obviously we want to use it maybe for something else later. Most AI is always certain that it's correct. So it gives you 100%. There's no uncertainty. Obviously, this is wrong. So that's the uncertainty that's coming out of the LLM. There will be, and I think there are already LLMs, but you need to look for those that have a mathematical uncertainty measure provided with the text output. A second approach is to use a second LLM for validation. AI validates AI. Has it flaws? Because if both are wrong, it leads to false impression that it's actually right. And the gold standard is human validation. In my job, we have radiologists actually correcting and validating AI answers. Here you basically need to make up your mind how you want to do this. Maybe Zoo point validations. So from, let's say, 40,000 rows, you select at random 200 and then see, okay, does this actually make sense? If it doesn't make sense, then you probably need to go back to either the prompt, refine this, but if the prompt looks good, then it's most like the model that is not good enough, and then switch to another model or just wait, come back 6 months later and try maybe an improved version of that model. The AI research answer would be you can build your own model. So those foundation models can be fine-tuned to your task. Maybe that's an effort where you can reach out to colleagues and maybe a couple of you have the same task. So you can join forces and then build your own in-house model in your institute that does exactly this data cleansing task really good